In this video, we're going to talk about the scientific method. And so the scientific method is an organized and logical way of testing a scientific claim, or in other words, a hypothesis. And so to start in the scientific method, you have to be observant. You have to observe the world around you. And for the example that we're going to go through for the rest of this talk, our example is we're observing the world around us, and I see, hey, every time I make chocolate chip cookies, they seem to be much thinner than the Mrs. Felds cookies I buy from the mall. Okay, so that's our observation. There's all kinds of different observations you can make. You can make one from just viewing the world around you, like this, or you could make observations from messing around with things. Well, I'm going to mess around with this and see what happens. Okay, but whatever observation you make, you need to go the next step. You need to be curious about it. You need to start asking questions. Okay, so you can't just make observations over and over and over again. You want to eventually ask some questions. And so my question then here would be, what is it that I can do in my recipe? How can I change my recipe to make my cookies as thick as the Mrs. Felds cookie? So now we have ourselves a question, and before we start experimenting, before we start doing anything, we have to sort of do some literature research, look into recipes, look into ingredients and the purpose of those ingredients. Because eventually what we want to do before we actually start an experiment is we have to make a hypothesis, our best guess answer to our scientific question. Okay, so our scientific question is, what can I change about my recipe to make my cookies as thick as Mrs. Felds? Well, I'm going to look through ingredients. I'm going to look at the ingredients of Mrs. Felds. I'm going to compare those to mine. I'm going to try to figure out what it is that may be the difference. So maybe after doing that research, I hypothesize then, I discover that I think that if I used cake flour instead of all-purpose flour, that now my cookies will be as thick as Mrs. Felds' cookies. So that's my hypothesis. Now, I don't know if that's true yet. I haven't actually done the experiment to test that, but this will guide me in what experiment I set up and how I set that experiment up. Because the next step now is to make a prediction. And so if I think that it's the cake flour, right, that makes those cookies thick, the Mrs. Felds cookies thick, and that cake flour will make my cookies just as thick, then I can make a prediction here. I can say, okay, based on the assumption that my hypothesis is true, what I can do is I can say, if I bake my cookies with cake flour instead of all-purpose flour, then based on the assumption that my hypothesis is correct, then my cookies should become as thick as Mrs. Felds' cookie. Now, remember, I haven't done any experiments yet. I haven't done any tests yet. I've simply made a prediction assuming my hypothesis, my hypothetical answer to my scientific question, is correct. Now we get to the next step. Now we get to the part where we make an experiment. But let's first define a few things. We need to define now what an independent variable is and what a dependent variable. Well, the independent variable is the thing that you are manipulating, the thing that your experiment is sort of testing, and that is flour type in our particular example. The dependent variable is the thing that you're going to measure, is the thing that you think is dependent upon your independent variable. So I think that the thickness of cookies, that's the dependent variable, is dependent upon the flour type. That's our independent variable. Okay, so the dependent variable is what we are measuring. and what we think is dependent upon our independent variable, what we are changing. So you give it a try. Let's make a hypothesis. The fat in cream is what allows cream to be whipped into a thick foam. That's our hypothesis. That's the hypothesis to the question of what is it about cream that allows it to be whipped into a thick foam. So pause this and figure out a prediction based on the assumption that this hypothesis is correct. Okay, did you give it a try? So here's a possibility. If I remove fat from cream, then it should be not able to be whipped into a thick foam. Or we can go the other route. If I add fat to milk, then that milk should be able to be whipped into a thick foam. You can go in either direction there. Next, we talk about the experiment. And to talk about the experiment, we first need to discuss experimental controls. We need something to compare our experimental to. Now, our experimental is what happens to the dependent variable when we change our independent variable. What happens to the thickness of cookie when I change my recipe to include cake flour instead of all-purpose flour. Okay, we have to have something to compare to. And so we compare it to two things. We compare it to the negative control, and we compare the results to the positive control. The negative control is the control in which the dependent variable does not change. Okay, so we're going to think of something in which the thickness of the cookies does not change. And so that's just the cookies made with my unchanged recipe. It's my original recipe. It's what I'm hoping my experimental will be thicker than, right? So it's the negative control then is going to give us the same results as if the experimental in the experiment did not work as predicted. The positive control is the control in which the dependent variable does change. Okay? It's going to give us the same results as the experimental if the experimental did work as predicted. So for example, for our positive control here, that's going to be our normal Mrs. Felds cookies. And then our experimental is obviously our cookies made with the modified recipe. And so what we're hoping to happen is that we start off with my original cookies that are thin. We are hoping to reach Mrs. Felds cookies, which are thick. And we are going to experiment by changing the flour that's in my original recipe and then measuring the thickness and hoping that it's now closer to or the same as Mrs. Felds cookies. Now, the thing that we're measuring and how we're going to measure, that's called your assay. Okay, and that's how we're going to measure the dependent variable, the thickness of the cookies. And our assay in this particular example is just a ruler. We're going to use a ruler to measure the thickness of the cookies. Now, some of you might notice I've got my units here as millimeters because we're all scientists here, so we use metric, but in the image here it's inches. Although, yeah, it's... So anyway, don't worry about that discrepancy there. So our experimental outcome, our results, we're going to record. And this is going to be your numerical data that you are using, that you are measuring using your assay. And so here we have our negative control, the unchanged cookie recipe that has an average cookie thickness of 2 millimeters. We have Mrs. Felds cookies. This is our positive control. They are 7 millimeters. And then our experimental, right, where we've taken our original recipe and we've replaced the all-purpose flour with cake flour, and we get 6 millimeters of average thickness. So this is our experimental outcome. We have a predicted outcome, what we predicted should happen, and then we have an experimental outcome, what actually happened. And notice our experimental outcome here, 6, is significantly much more similar to our positive control to 7 than it is to our negative control 2. And that's how you make your conclusion. You basically take a look at your experimental outcome and you compare it to your predicted outcome. We predicted that when we change the flour type that our cookies will become as thick as Mrs. Felds. That was our predicted outcome. We did the experiment and we got the results. We got our experimental outcome. And then we compared the two, experimental outcome, predicted outcome. If the two match, then your data supports your hypothesis, and you can conclude that yes, indeed, it seems that cake flour does contribute to the thickness of cookies. If the experimental outcome does not match what you predicted would happen, if you did not see an increase in thickness, then you must either reject or modify your hypothesis. And by modify, I mean, you might say, well, I think it is cake flour, but in addition, it's this, this, and this. Or, okay, maybe it's not cake flour, maybe it's this. And so you modify, you reject your hypothesis, and then you come up with a new hypothesis and you do an experiment again. And you keep doing that and doing that and doing that. And eventually you come up with a hypothesis in which your data supports.